For the majority of this video, I will be showing you how to use sine, cosine, and tangent to find unknown sides and angles. However, there will be a little Pythagorean theorem involved and a couple other minor theorems as well. Okay, so problem number 1. Find the sine of angle U. So as soon as I see that we're talking about sine, cosine, or tangent, I know that I should label the hypotenuse. So the hypotenuse is across from the 90-degree angle, so that makes this the hypotenuse. Next, you should circle the angle that you're talking about. So we're supposed to find the sine of angle U. So let's circle angle U and draw an arrow going away from that thing. That will point at the opposite side. The other side is called the adjacent side. Now, Sohcahtoa, which often I'm just going to write like this, S-O-H-C-A-H-T-O-A, this is an acronym that will remind me that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In this case, they are specifically asking us to find sine. So that means I definitely need to look at the first one. Opposite over hypotenuse, that will be 12 over 13. So that's why the answer is C. Okay, problem number 2. Find the tangent of angle S. Well, again, we start with the hypotenuse. Circle the angle that you're talking about. This time it's S. Draw yourself an arrow. That will tell you the opposite side. The other side is the adjacent side. Now, tangent is opposite over adjacent. So that's going to be 5 over 12, which is B. Okay, which triangle would require sine, cosine, or tangent to find the value of? Okay, to find the value of x. Well, I would not need sine, cosine, or tangent to find the value of x right here because I would just subtract from 90. I could just do 90 minus 55, and that would give me the answer. I will not need, so A is not the answer. I will not need sine, cosine, or tangent here either, because this will be the Pythagorean theorem. This is where I would do a squared plus b squared equals c squared. Notice that these are all sides. So when I'm dealing with only sides and no angles, that's when it's all about the Pythagorean theorem. So the answer is not B. That's the same reason for C as well. Again, it's all sides. We're not given an angle. We're not looking for an angle. It has nothing to do with angles. It's only sides. So again, that would be the Pythagorean theorem. So D has to be the answer. And as we look at it, we see that we have an angle, and then we're being asked to find a side. So this would be a perfect time to do sine, cosine, and tangent. All right, I'm going to switch colors real quick, going into problem number 4. Which equation is set up correctly? Well, let's label everything. Clearly, we're dealing with sine and cosine. So always start by labeling the hypotenuse, which is across from the 90-degree angle. Then circle the angle that you are given, draw an arrow, and that will tell you the opposite side. The other side is the adjacent side. Okay, now keep in your mind Sohcahtoa. Sohcahtoa. All right, well, we've got sine and cosine here, so let's just set those up. So sine is opposite over hypotenuse. So if I was doing sine, I would go sine of the angle circled, which would be 50, is equal to opposite over hypotenuse. There's nothing there. We don't know the opposite side. So right away, I know that sine is not going to be the answer. So I know that A and B are wrong because there is nothing on the opposite side. So there's no way we could do sine. All right, so that's no good. So it's going to be one of these. So let's talk about cosine. Cosine of 50 degrees, all right, cosine of the angle. Cosine is adjacent over hypotenuse. So that would be 31 over x. So 31 over x. So this is the correct setup. So I'm just going to look for that. So here I see that D is cosine 50 equals 31 over x. So the answer is D. All right. Ponder number 5 while I change the color of my pen. Solve this equation. Well, solving these equations depend on where the variable is. When the variable is in the top, that's when you multiply. So specifically, I will multiply both sides of the equation by 14. That will cancel these out. So in my calculator, I will just do 14 tangent 22. All right, 14 tangent 22. 5.656. All right, and that is B. All right, ponder number 6 while I change colors. Solving this equation. When the variable is inside the trig function, this is when we do the inverse. All right, so again, when the variable is in the numerator, that's when you multiply. But when the variable is right next to the trig function, that's when you do the inverse, which looks like this. So instead of tangent, I will do inverse tangent with that little -1. And I will do the inverse tangent of this fraction. And that will give me x. So inverse tangent of 21 over 25. So inverse tangent, so I do second tangent, 21 over 25. 40.030. Okay, that is B. All right, take a gander at problem number 7. Find the value of x, 3 decimal places. Okay, again, this is going to be the Pythagorean theorem. I know that because there are no angles involved. I'm given 2 sides and I'm looking for the third side. So we're going to do the Pythagorean theorem like a squared plus b squared equals c squared style. But please remember that the c is always the hypotenuse. So we still need to identify the hypotenuse. This is the hypotenuse. It's across from the 90-degree angle. So the 36 has to go by itself. So I will have 26 squared plus x squared is equal to 36 squared. All right, to the calculator. 26 squared, 676, plus x squared. Now 36 squared, 1,296. Then I need to subtract 676 from both sides. And that will give me x squared. So that is 620. And finally, I must take the square root of both sides. So I take the square root of 620. All right, if I get a radical like this, I'm going to hit this button to give me the decimal. 24.899. But I have to round up because of the 7. So look at it this way, 899. If I round up 1, that would be 900. So 24.900. Okay, and that is A. Okay, ponder number 8. Find the value of x. Okay, this is going to be sine, cosine, or tangent because I'm looking for an angle and I've got sides that are given. So I need to start with the hypotenuse, which is right here across from the 90-degree angle. Then you circle the angle that you are looking for and you draw an arrow. The arrow points at the opposite side, and the blank side here is the adjacent side. So now it's time to think in terms of Sohcahtoa. Sohcahtoa. Which one am I going to use? Well, look at the two sides that we are given, 26 and 36. That is opposite and hypotenuse. So that means the sine function, because sine is opposite over hypotenuse. Okay, so let's write down sine. Sine of the angle we circled, which is x, is equal to opposite over hypotenuse. So that's 26 over 36. As I mentioned a moment ago, when the variable is inside the trig function, this is when you inverse. So I will do inverse sine of 26 over 36. And that will give me the answer. Okay, so inverse sine of 26 over 36. 46.238. Okay, well, there it is right there, D. All right, what is next? Problem number 9. Okay, it looks like another sine, cosine, or tangent problem. So let's start by labeling the hypotenuse. Circle the angle that you were given and draw yourself an arrow. That'll be the opposite side. The other side is the adjacent side. So we will write Sohcahtoa. Which one are we going to use? Well, look at the sides that we are dealing with. We have 8 and x. That's opposite and hypotenuse. So that's going to be the sine function. Sine is opposite over hypotenuse. So we write sine of the angle we circled, opposite over hypotenuse. So that'll be x over 8. When the variable is in the numerator, that is when you multiply. So we will multiply both sides by 8. And that will cancel these out. And then you just put this in your calculator. 8 sine 53. 8 sine 53. 6.389. All right, check out number 10. Yep, it's another sine, cosine, or tangent problem. Start with the hypotenuse, which is right here. Circle the angle that you are given, draw an arrow. That will point at the opposite side. The other side will be the adjacent side. Now write Sohcahtoa. Which one are we going to use? Look at the sides. We have x and 15. That's opposite and adjacent. So that tells us to use the tangent function, which is opposite over adjacent. So we will write tangent of the angle we circled is equal to opposite over adjacent, so 15 over x. All right, so this is the first time we see the angle in the denominator. When the angle is in the denominator, this is when you swap. All right, we're going to swap this and this. All right, these are going to swap. And this is what you do whenever the variable is in the denominator. So the x is going to come over here by itself. And then the 15 is not going to move, but the denominator will be tangent 48. And then you put this in the calculator, 15 over tangent 48. $13.506. Alrighty then. Number 11. Interesting. Oh, okay, another sine, cosine, or tangent problem. Always start with the hypotenuse. It is across from the 90-degree angle. Then circle the angle that you are looking for and draw an arrow. That'll be the opposite side. The other side is the adjacent side. Now write Sohcahtoa. Which one do we use? Look at the sides. We're given 12 and 23. That's adjacent and hypotenuse. That is cosine. Cosine is adjacent over hypotenuse. So we will write cosine of the angle we circled, which is x, is equal to adjacent over hypotenuse, which is 12 over 23. When the variable is inside the trig function, this is when you inverse. So that's why we will go inverse cosine of 12 over 23. And that will equal x. Calculator time. All right, inverse cosine of 12 over 23, 58.551. Whoa. All right, great. Moving on. All right, so we're going to use this picture for multiple problems. So we don't have to mark on this picture up here because they've recopied the picture for us 3 times. So we'll use these. So, okay, we need to find the length of side ED. All right, so if they want us to find the length of a certain side, we'll put an X there. Okay, so we'll put an X. Okay, I thought that was going to be black. So this will be a sine, cosine, tangent problem. So let's start with the hypotenuse like we always do. The hypotenuse is across from the 90-degree angle. Next, circle the angle that you are given and draw an arrow. This will indicate the opposite side. The other side is adjacent. Now write Sohcahtoa. Okay, which one are we going to use? Well, look at the sides. We have x and we have 12. That's opposite and adjacent. So that is the tangent function. Tangent is opposite over adjacent. So we will write tangent of the angle we circled is equal to opposite over adjacent. So that is x over 12. When the variable is in the numerator, this is when you multiply. All right, you multiply by that 12. All right, that way these 12s cancel each other out. And you just put this in your calculator. 12 tangent 35. $8.402. All right, how about number 13? This is going to be another sine, cosine, tangent problem. But first, we need to put an x on here somewhere. Find the length of side DF. So let's put an x on side DF. For some strange reason, my black pen doesn't work. So I am using dark brown. Don't tell anybody. So DF is right here. All right, let's put the x. Now, let's start by labeling the hypotenuse, which is always across from the 90-degree angle. Then circle the angle that you are given and draw an arrow. This will tell you the opposite side. The other side is adjacent. Now, write Sohcahtoa. Which one are we going to use? Look at the sides. We have 12 and we have x. That's adjacent and hypotenuse. That tells us that we will use cosine because cosine is adjacent over hypotenuse. So we will say cosine of the angle that we circled is equal to adjacent over hypotenuse. So that'll be 12 over x. All right, when the variable is in the denominator like this, this is the one where we swap. All right, we're going to take the cosine 35, and we will take the x, and we're going to swap these. So the x will end up over here. The 12 will stay where it is, but the cosine 35 will end up in the denominator. And this is something you can put in your calculator, 12 over cosine 35. $14.649. All right, on to number 14. Okay, now we are supposed to find the measure of angle D. Interesting. So here's angle D, so I'm going to put an X right here. So the question is, do we need to do sine, cosine, or tangent? Absolutely not. We do not need to do that. I don't think we even have enough information to do that. We're given one angle, and we're being asked to find the other angle. So this is really easy. These two angles have to add up to 90 degrees. So the quickest and easiest thing to do is just do 90 minus 35. All right, which you should be able to do in your head, but I'm going to just punch it in so you can all see what I'm doing. All right, so that's going to be 55. All right, moving on. All right, we are almost done. We just have a few word problems. Okay, we have a 12-foot ladder leaning against a wall. It forms a 78-degree angle with the ground. How high up does the ladder go? First, we have to choose the correct picture. Okay, the 78-degree angle is with the ground. So first of all, we can throw out the pictures where the angle is not on the ground. So we can forget about picture C and picture D. So it's going to be one of these. How high up the wall does the ladder go? So this is the X, the height of the ladder on the wall. So that is going to be this one. Okay, this X is how far up the wall the ladder goes. All right, they didn't say how long is the ladder. That's what B is doing. So the answer is A. This is the picture that we're using. A. Okay, so great. Now let's find the value of X. So this is definitely a sine, cosine, tangent problem. So as usual, we will label the hypotenuse first. Here it is across from the 90 degrees. Next, we circle the angle that we are given, and we draw an arrow. That arrow points at the opposite side, and the other side is the adjacent side. And then we go, okay, Sohcahtoa. And which one are we going to use? Look at the sides. We've got the X and we've got the 12. That's opposite and hypotenuse. So sine is opposite over hypotenuse. So that's what we need to use. So we will use sine. Sine of the angle we circled is equal to opposite over hypotenuse. So that's going to be X over 12. Okay, when the variable is in the numerator like this is when you multiply. You multiply by 12. All right, you multiply by the denominator on both sides. That way these will cancel out and you get X by itself. This is something you can put in your calculator. 12 sine 78. $11.738. Got to round up. 11.738. All right. New problem. An ant stands on the ground 300 feet away from the base of a building that is 70 feet tall. What is the angle of elevation from the ant's position to the top of the building? All right, so looks like we have to draw our own diagram. Scary. So, okay, here's the ground. And here's my building. And here's my ant. Dink. There's my ant. And here is the angle of elevation. All right. So let's put some numbers in there. The ant is 300 feet away from the base of the building. So that means that this is 300 feet right here between the ant and the base of the building. The building is 70 feet tall, so that means this height is 70. All right, straight up and down, so the 90-degree angle goes here. What is the angle of elevation from the ant's position? So the angle of elevation will be this right here. Okay, so this is the picture. So let's go ahead and label everything. This is clearly a sine, cosine, tangent problem. So we will label the hypotenuse first, as we always do. And then we will circle the angle that we are looking for, and we'll draw an arrow. The arrow points to the opposite side. The other side is adjacent. All right, great. Time to say Sohcahtoa. Which one are we going to use? Well, you have to look at the sides. We have the 300 and the 70. That's opposite and adjacent. That tells us that we will be using the tangent function, which is opposite over adjacent. So we will write tangent of the angle we circled is equal to opposite over adjacent. That's 70 over 300. All right, when the variable is inside the trig function, this is when we inverse. Okay, so I will write inverse tangent of 70 over 300. And that should give me x. All right, inverse tangent of 70 over 300. $13.134. All right, and we're talking about an angle, so this will be degrees. Okay, how about number 18? The angle of elevation from the ant's, find the angle of elevation from the ant's position. Wait a minute. Oh, okay, I guess they're breaking this up into two different problems. So I guess number 17 was just drawing the picture. And then number 18 is finding the answer. So we really already did problem number 18 by accident. So I'm just going to copy this, move it down here. Does it fit? Okay, so clearly this is the answer. All right, I guess I need to write it a little smaller. So it will fit on the line. So 13.134 degrees. All right, is everybody happy? Great. All right. Looks like we're down to the last problem. Other than, looks like there's a bonus. Okay, so what are we dealing with? A cable that is 180 feet long connects the top of a tower to a stake in the ground, forming a 65-degree angle. How tall is the tower? Okay, all of the angles are in the right position, so I don't have to worry about that. The cable is 180 feet long. So clearly this is the cable right here. So this 180 is in the wrong place, so it's not going to be this one. All right, this 180 is not where the cable is, so that's not going to be it either. It's going to be C. This is the only one that has the cable in the right spot. Okay, and how tall is the tower? And so X is in the right spot, being the height of the tower. So this is the picture that we shall use. Now what? For the picture you choose, find the value of X. So this is still sine, cosine, and tangent. Start with the hypotenuse, which is clearly right here, across from the 90-degree angle. Circle the angle that you're given and draw an arrow. That will be the opposite side. The other side is adjacent. Now, if we write Sohcahtoa, we can start thinking about which one we're going to use. All right, well, look at the sides. We have x and we have 180. That's opposite and hypotenuse. That sounds like the sine function. Sine is opposite over hypotenuse. So let's write sine of the angle we circled is equal to opposite over hypotenuse. That's x over 180. When the variable is in the numerator, you multiply. You multiply by the denominator. So we will multiply both sides by 180. That way these will cancel each other out. And this will give us the answer in the calculator. 180 sine 65. That's 163.135. All right, great. So that just leaves this bonus problem. Eric's eyes are 6 feet above the ground. Okay, so that means we have 6 feet like right here. All right. He stands at a free throw line, which is 15 feet away from the goal. So that means we have 15 feet right here. You know what I mean? Like from here to here is 15 feet. What else? He looks up at the hoop. The angle of elevation from his eye level is 14.8 degrees. So I'm going to put this 14.8 degrees at his eye level, like they said. Great. How high above the ground is the hoop? So we need to find this question mark is the height above the ground. All right, we're going to have to do this in 2 stages. Because we have this triangle, our right triangle is floating up here in the air. So we need to start by finding this distance right here where I just put this x. When we find x, that will not be the final answer, but we'll be able to find the answer from there. So let's find x. So this is going to be a sine cosine tangent problem. So we will start with the hypotenuse, which is across from the 90 degrees. Next, we will circle the angle given and draw an arrow. That will point at the opposite side. The other side is adjacent. Okay, we think Sohcahtoa. And we ask ourselves which one we are going to use. Well, look at the sides. We have the x and we have the 15. All right, don't forget that even though the 15 is like way down here, all right, the distance from the person, from Eric to the goal is 15. So that'll be the same as this length on the triangle. So this is 15 right here. This side of the triangle is 15. Okay, now let me put that adjacent back again. Okay, so we have the x and we have the 15. That is opposite and adjacent. Opposite and adjacent. So that is the tangent function. Tangent is opposite over adjacent. So let's write tangent. Tangent of the angle we circled is equal to opposite over adjacent. So that'll be x over 15. All right, when the variable is in the numerator, this is when we multiply. We multiply by 15. We multiply by the denominator. All right, that way these are going to cancel each other out. So we can put this in the calculator, and that will give us x. 15 tangent 14.8. .963. Okay, so that is x up here. But that is not the answer. So let me just make this really, really clear. We just found x right here. So let me erase the x for a second. Okay, so we just found this, which was this distance right here. And we just found that this distance right here is 3.963. But we want to know the entire distance all the way to the ground. So what am I going to do? How do I find the whole distance? Well, the thing is, we know what this distance is right here, don't we? That's the height of Eric's eyes. So we know that this is going to be 6. All right, so if we want to find the height, the total height, we just need to add these two numbers together. And that will give us the total height that we're looking for. Okay, so if I add 3.963 plus 6, that is going to equal 9. Do they give us an answer line? Okay, that's going to give us 9.963. All right, and that is how you do the bonus question.